Good day, I'm Dr. Alison. I'm a postdoctoral researcher at the University of Pretoria in the Anatomy Department, and more precisely the Forensic Anthropology Research Centre. Therefore, today I will present my research project that will be conducted during the next 2 years. This research focuses on sex estimation of South African human pelvis using a 3D geometric morphometric approach for forensic analysis. Identifications of unknown persons is a challenge in South Africa. For example, in 2021, approximately 900 bodies were left unidentified in Gauteng mortuaries. In response to this crisis, FARC's forensic anthropologists collaborate with the South African Police Services to analyze skeletal remains and provide estimations on sex, population affinity, stature, and age, as well as traumatic injury to bone and pathology. Several studies have shown that sexual dimorphism expressions is highly population-specific. Therefore, the probable identification of an unknown individual is based on quantifiable phenotypic variations and the relationships of these variations to the individual's socio-cultural identity. Gender represents the phenotype, while biological sex is individual's genotype. Sex is defined as the biological characterization of sexually reproducing species and exhibit inter- and intra-population variability. The oxoxa appear to be one of the most reliable bonds of the human skeleton to determine sex for exhibiting the reproductive differences and allowing for parturition in females. These shape changes could be explained by increasing hormonal activity during puberty or functional adaptations to specific locomotion modes and maternal-fetal size relationships. Furthermore, these morphological differences strongly depend on nutrition, occupations, geographical origins, and population affinity. As significant differences in population affinity-related variations based on morphological trait, growth patterns, and aging between sexes exist, an accurate assessment of sex is based on quantifying and interpreting the expression of sexual dimorphism in a population. Several sex estimation techniques have been developed over the last 20 years. These approaches can be classified as no-metric, metric, molecular techniques, diagnostic, probabilistic, and geometric morphometric methods. Forensic anthropologists at the FARC employ both morphological and osteometric methods on cranial and postcranial remains to estimate the sex of an unknown person. The morphological approach for sex estimation has been extensively criticized due to the subjectivity involved in the procedures and the fact that the reliability is highly dependent on the observer's experience. Although the osteometric approach, namely linear discriminant function analysis, to sex estimations is the most widely used in forensic anthropology and appears to be more structured and accessible than the morphological techniques, significant inter- and intra-observer discrepancies have been noted for pelvis dimensions. Furthermore, linear discriminant analysis requires a suite of measurements to be taken for sex to be accurately estimated, which is problematic when the bones are burnt or fragmentary. Geometric morphometrics is a field that focuses on biological shape analysis using 3D Cartesian coordinates of anatomical landmarks. Several studies using geometric morphometric methods to analyze pelvis-related shape variation for sex estimation conclude that geometric morphometric method and multivariate statistic are both accurate methods to quantify pelvis shape differences between the sexes. The utilization of geometric morphometric methods for sex estimation using the pelvis is preferable to metric methods because they retain the object's geometric and analyze subtle differences among structures. Furthermore, geometric morphometric methods could significantly overcome the exclusion of fragmented pelvises in the sex estimations analysis by creating discriminate shape matrices to analyze specific patterns not readily observed with a morphological approach. In a real-life application, the utilization of 3D imaging approaches might be more reliable and efficient than traditional methods. However, researchers need a practical 3D scanning modality and an approach to extract 3D anatomical information, along with advanced statistical analysis. All three of these tools will permit forensic anthropologists to estimate the sex from fragmentary remains in a more accurate and repeatable way. To this end, the purpose of this project is to examine the morphology of the host coxa among three socially defined population groups as a means to estimate sex using geometric morphometric methods and to develop standard operating procedures for using a 3D surface scanning modality in forensic anthropology case analysis. The first objective would be to collect 3D pelvis shape data. The second objective is to assess sex variation-related pelvis shape matrices using geometric morphometric methods among population groups, then to test for sex variation-related pelvis shape matrices using specific discriminant matrices to overcome missing pelvis elements. The fourth objective would be to create prediction models based on geometric morphometric learning procedures using biological shapes to create presumptive identifications in forensic contexts. And finally, a standard operating procedures for 3D sex estimation using 3D surface scanning modality for forensic analysis will be created. Modern adult pelvis of black-colored and white South Africans from the Backing South Africa repository, which is housed at the University of Pretoria, would be collected. The scanning modalities used would be micro-CT, CT, and surface scans. A minimum of 60 individuals by demographic groups would be required, following the availability of the material for the regions of interest studied. Ethical clearance was obtained from the Research Ethics Committee of the Faculty of Health Sciences at the University of Pretoria to use all previously and additional anonymized scans. For scanning modality generating DICOM or TIFF images would be imported into Aviso software, already available at FARC, for segmentation and 3D surface model generation. On the scans, gray values encode the density of the observed material, like a standard X-ray image. The lighter the gray values, the denser the tissue's intrinsic structures. The bone material will be then partitioned and extracted from all other materials or noise present in the scan, resulting in the generation of 3D reconstructions saved in polygon file format. Anatomical landmarks are defined by specific biological structures and are thus consistent across all individuals of a species. In these studies, standard anatomical and semi-landmarks will be designed to reflect the pelvis shape in the best possible manner, resulting in 18 anatomical and 257 semi-landmarks. The four sets of semi-landmarks will be placed using an interpolation algorithm of 1 mm. The automatic placement of landmarks and semi-landmarks approach used in this research is adapted from our recently published procedure. The basic concept involved a reference template of the anatomical surface of interest, containing a dense set of landmarks and semi-landmarks. First, a reference template will be created using a non-rigid surface registration procedure. Surface registration refers to the establishment of the geometrical relationship between 3D reconstructions that aligns the surfaces as well as possible between them. Then, every individual surface is templated, named the warped surfaces. This means that every point on all 3D surfaces is associated with the anatomically corresponding point on the reference template. In the last step, landmarks are indicated once on the reference template. Every landmark on the template is associated with the atomically corresponding point on the warp surfaces. During an atomical templating process, this reference template is warped non-rigidly to every subject's anatomically corresponding surface. The non-rigid surface registrations software used for this warping was developed using the MeVisLab software in collaboration with Prof. Dirk van der Meulen from K11 University. The warping is performed iteratively, starting with a rigid alignment and gradually with more flexible registration steps. At the end of this process, every landmark on the template is projected onto every subject surface, establishing a dense point-based anatomical correspondence between all subjects. The Cartesian coordinates representing pelvis-shaped matrices will be then recorded for statistical analysis. The automatic placement of anatomical and sliding landmarks on 3D models for shape analysis of the human pelvis was already validated as compared to a manual placement in a study conducted by my BSc honor student Ms. Thandolwethu. The sex estimation analysis on shape matrices acquired will be visualized and quantified through the application of geometric morphometric methods. A generalized procrust analysis would be performed on the Cartesian coordinates to obtain orientation invariant shape coordinates. A principal component analysis would be performed to assess sex-related pelvis shape variations among each population group by creating independent transformed variables referred to as principal component scores. Before applying statistical testing, the PC scores distributions will be analyzed using multivariate normalities testing conducted through the interpretation of QQ plots to allow the presumption that the variable is distributed according to the distribution tested. Significance of sex affect among the population studied will be assessed using standard MANOVA, 50-50 MANOVA, and permutation testing. Standard discriminant function analysis will also be applied for classification purposes. The classification accuracy will be estimated by conducting a leaving one out cross-validation. Finally, projection onto latent structures would be used in this study to extract information for the prediction model and to select those linear combinations relevant for explaining the predictor variable, maximizing covariation between predictors, shape matrices, and response sex variable. Although a sizable 3D scanning modality exists in osteology and anthropology, developing new advanced methods and techniques involving 2D scanning modalities for real-life forensic applications required accessibility and practicality. The application of 3D scanning modalities such as photogrammetry, 3D surface scanning, and micro-CT scanning is frequently used in osteology and anthropology. However, using a micro-CT scanning modality could be counterproductive and challenging to integrate into forensic analysis due to the cost and the time consumption generated. Compared to the micro-CT modality, photogrammetry and 3D surface scanning modalities do not require X-ray computed tomography and professional training. Consequently, they appeared to be the ideal modality to be integrated into forensic analysis by making the scanning procedure more accessible and easier to utilize for forensic anthropologists. In contrast to 3D surface scanners, most photogrammetric procedures capture only shape information, raising a primary limitation in its practicability and accuracy in its utilization into a forensic analysis procedure. Finally, the 3D surface scanner has proven more consistent in 3D reconstruction generation than photogrammetry software packages. Therefore, the introduction of the 3D surface scanning modality might provide an efficient set of advanced techniques complementary to the existing metric forensic analysis. A standard operating procedure for 3D sex estimation using surface scanning modality for real-life forensic analysis applications will be created and made available to analysts at the end of this research project. Purposes, scope, definitions, terminology, roles, and responsibility will be provided, as well as a complete detailed procedures, including the surface scanning, landmarking, and statistical analysis. In South Africa, due to the high number of unidentified bodies, many of which are burned and fragmented, as well as the population's substantial heterogeneity, a need exists to develop innovative approaches. The fact that new 3D imaging methods might allow forensic analysts to assess specific sexual dimorphism patterns not readily revealed by the non-metric and metric methods, it does not undermine the significance of already widely used methods for sex estimation in forensic anthropology. Current metric approaches for sex estimations almost exclusively relied on conventional craniometric measures derived from landmarks that are mostly manually indicated. Such manual placement of landmarks is extremely time-consuming and may induce important observer subjectivity and errors in placing these landmarks. These limitations could be overcome by applying the automatic placement of landmarks and semi-landmarks methods developed at FARC, offering increased objectivity, consistency, and the possibility of standardization. In forensic cases, real-life applications, reliable, accessible, and more efficient methods using 3D imaging approaches involving practical 3D scanning modality, accurate 3D anatomical information extraction, and advanced statistical analysis might allow forensic anthropologists to estimate the sex in a more accurate and repeatable way. Consequently, it might provide a more efficient biological profile to solve forensic cases and improve existing analysis. Thank you for your time. If you have any questions, please feel free to contact me by email. Thank you.